then we have to prove that tan A plus B minus tan A minus B. This is equal to sin 2B divided by cos square B minus sin square A. We have proved this one. Now we'll start from LHS. Tan A plus B minus tan A minus B. Now here we can see the RHS we need in terms of sine curves. So here also you have to split up in sine and cos. So what we get here, sine A plus B by cos A plus B. Next one, sine A minus B by cos A minus B. After that we take the LCM. If we take the LCM, it is cos A plus B into cos A minus B. Now, if we take the LCM, sin A plus B into cos A minus B, cos A plus B into sin A minus B. So on taking LCM, sin A plus B into cos A minus B minus cos A plus B into sin A minus B. This one. Now, if you see this expression, this is as if we have sin A cos B minus cos A sin B. Now sin A cos B minus cos A sin B, and that is what sin A minus B. So this is giving us what? A plus B minus A minus B by cos A plus B to cos A minus B. The formula is what? Cos square B minus sin square A. Just we're using the formula of cos A plus B to cos A minus B in the denominator. In the numerator, if we simplify this, A cancel out B plus B 2. So sin 2B by cos square B minus sin square A. So what we had, tan A plus B minus tan A minus B. So tan A plus B minus tan A minus B. This is sin A plus B by cos A plus B. This is sin A minus B by cos A minus B. Now we have taken the LCM, cos A plus B into cos A minus B. Now if you take the LCM here, sin A plus B into cos A minus B, sin A minus B into cos A plus B. Now sin A cos B minus cos A sin B, that is sin of A minus B. We have simplified this, we got 2. Cos A plus B to cos A minus B, cos square B minus sin square A, and this is what we need. Here tan beta is given, that is n sin alpha cos alpha by 1 minus n sin square alpha. And what we have to show, tan alpha minus beta equal to 1 minus n tan alpha. So this is also based on tan A minus B formula, as you can see here, tan A minus B, which have to use. So since you can see here that tan A minus B have to use, so just you can start in that way, that we have tan alpha minus beta equal to tan alpha minus tan beta by 1 plus tan alpha tan beta. This is the formula. Now after that, what? Now the concept is same as we have done the previous sum. What we have done? We have split it out in sine and cos. Now here also why? Tan beta is given in terms of sine and cos. So here also, if we use tan beta in terms of sine and cos, alpha also should be taken in terms of sine and cos only. Because then only the calculation, or you can say the operation, addition, multiplication, whatever you do, simplification, whatever you do, that will be helpful for you. So we simplify. Tan alpha we take as sine alpha by cos alpha. Tan beta in sine alpha cos alpha whole divided by 1 minus in sine square alpha whole divided by 1 tan alpha, that is sine alpha by cos alpha, into we have in sine alpha cos alpha whole divided by 1 minus in sine square alpha. Now after this we'll take the LCM as we have done the previous sum, same thing. We'll take the LCM here. In the numerator as well as the denominator. So this is cos alpha into 1 minus in sine square alpha. So this will be sine alpha minus in sine cube alpha minus in sine alpha cos square alpha. See, this into this sine alpha into 1 sine alpha into in sine square alpha in sine cube alpha minus this one in sine alpha cos square alpha. Denominator same. Next we take this one, that is what cos alpha into 1 minus in sine square alpha. Now if you take the LCM, this will be cos alpha. So this is cos alpha, then minus in sine square alpha into cos alpha minus in sine square alpha cos alpha plus in sine square alpha cos alpha. Now here also you can see this and this cancels. These two are getting cancelled. Exactly whatever we have done in the previous sum. Now the next part. Next part, what we do? In the numerator, we keep sine alpha as it is. We keep sine alpha as it is. From the next two, we take n sine alpha common. From the next two, we take n sine alpha common. So what we get? We get sine square alpha plus cos square alpha. Next, from the denominator, this and this cancels out. So what we are left with? Cos alpha. This and this cancels out. Now this is 1. So from the numerator now, you can take sine alpha common. Denominator we have cos alpha into 1 minus n. If you take sine alpha from here common, sine alpha into here 1, here minus n. Now this gives us what? 1 minus n into tan alpha. And we're done. It is m tan theta minus 30 equal to m tan theta plus 120. We have to show what? 2 cos 2 theta equal to m plus n by m minus n. So this is what we have to show. Now, here, how to understand is the component dividend to sum? This one, children. We have to prove this one, no? So this is telling you to do so. This is telling you to do so. So here you take m by n on one side and rest on the other side. Tan theta minus 30. Now there's a thing here, that's in this case, obviously you can apply component dividend. There's no problem. You can directly apply and then you can think also. Suppose you want that to know, I don't want to think anything. I know this component dividend and I'll directly apply component dividend. So no issues. You can do that using component and dividend. So what we get? M plus n by m minus n is tan theta plus 120 plus tan theta minus 30 whole divided by tan theta plus 120 minus tan theta minus 30. Now, since you need in terms of cos to split up in sin and cos, since you need in terms of cos, you split up in sin and cos. So theta plus 120 by cos theta minus 120 plus here sin theta minus 30 by cos theta minus 30 whole divided by 2. It is sin theta plus 120 by cos theta 120 sin theta minus 30 by cos theta minus 30. Now after that we'll simply take LCM. If we take LCM here, this into this plus this into this, all of you know how to take LCM, children. So this, if we take LCM, sin this one into cos this plus cos this one into sin this one. Here sin this angle into cos this whole thing minus cos this into sin this. So what do we write? We take here LCM cos theta plus 120 cos theta minus 30. So we have here cos theta plus 120 and cos, here you can see cos 120, theta plus 120 and cos theta minus 30. So that we have taken LCM, this one. Now in the numerator what we'll have? Sin theta plus 120 into cos theta minus 30. In between what you had? In between you had plus. So here we'll take plus sign. Plus cos theta plus 120 into sin theta minus 30. Here cos theta plus 120 into cos theta minus 30. So whatever you have here, same thing you got. Now same thing, just a minus sign in between. Whatever you got in the numerator, same thing you'll get, just a minus sign in between. The two product. Minus cos theta plus 120 into sin theta minus 30. Now you can see here, this cancels out. Now, what we have? Sin A cos B. Sin A cos B plus cos A sin B. Sin A cos B plus cos A sin B. What is the formula, children? Sin A plus B. Theta plus 120 plus theta minus 30. Here sin theta plus 120 minus theta minus 30. So this will be what? Sin 90 plus 2 theta by sin 150. Now children, 1 into 90, odd multiple of 90, this will become what? Cos 20, cos 2 theta. And here sin 150. What is the value of sin 150? You can do it separately also if you want. Sine 150 means 1 into 90 plus 60. 1 means it will be cos 60. That is in which quadrant? 1 into 90 plus 60, that means it is in the second quadrant. Second quadrant sign is positive. So here you can put half. That gives you what? 2 cos 2 theta. Cos beta minus gamma plus cos gamma minus alpha plus cos alpha minus beta equal to 3 by 2. This is given condition. What we have to show? We have to show here cos alpha plus cos beta plus cos gamma equal to 0 and sin alpha plus sin beta plus sin gamma equal to 0. This is what we show. And once we're showing that, after that we have to do another thing. That is, you can see hence deduce that cos beta minus gamma equal to cos gamma minus alpha equal to cos alpha minus beta equal to minus. So this is the given information. Next we have to prove this one. This is what is given to us. Now from the given part, at first we should try to find out this one, this relation. How? See, let us start. We have 2 cos beta minus gamma plus 2 cos gamma minus alpha plus 2 cos alpha minus beta equal to minus. Just have transferred 2 on the left hand side. After that, just use vitamin formula. All of us know the formula of this one: cos beta minus gamma, cos A minus B formula. That is cos beta cos gamma plus twice sin beta sin gamma plus 2 cos gamma cos alpha plus 2 sin gamma sin alpha plus 2 cos alpha cos beta plus 2 sin alpha sin beta plus 3 equal to 0. Here we have minus 3, so we have taken 3 on the left hand side. Change of sign means change of sign. Plus 3 equal to 0. Now after this, you can see this is a 2AB format. You have now this 3 we can split up as 1 plus 1 plus 1, and that each one we can write as cos square alpha plus sin square alpha, cos square beta plus sin square beta, cos square gamma plus sin square gamma. Here we have 3. Here we have split up in formula of cos A minus B, 2 cos A cos B plus 2 sin A sin B. Taking the same format, we have done the whole thing. Now, since we have to find cos alpha plus cos beta plus cos gamma equal to 0, this we have to show. We'll try to bring that one. Cos alpha plus cos beta plus cos gamma. So how? This is already you have 2AB, 2AC, 2AB format. So what we need now, a square plus b square plus c square. For that, you can split up this 3. So by splitting up this 3, what we can write is 1 we can write cos square alpha plus sin square alpha plus cos square beta plus sin square beta cos square gamma plus sin square gamma plus 2 cos alpha cos beta. We have here 2 cos alpha cos beta, just I have written it. After this, just the order has been changed. Plus 2 cos beta cos gamma plus 2 cos gamma cos alpha. Just I'm taking the cos part together and then I write the sin beta. 2 sin alpha sin beta plus 2 sin beta sin gamma plus 2 sin alpha sin gamma is equal to 0. Now, after that, we'll take all the cos together and all the sin together. Now, we take all the cos together. So, cos square alpha plus cos square beta plus cos square gamma plus 2 cos alpha cos beta plus 2 cos beta cos gamma plus 2 cos alpha cos gamma. This we take together and the sine part also we take together. That is sine square alpha plus sine square beta plus sine square gamma plus 2 sine alpha sine beta plus 2 sine beta sine gamma plus 2 sine alpha sine gamma equal to 0. So what we have done, we have taken all the cos together in one bracket, all the sine together in the other bracket. Now here you can think it in this way: a square plus b square plus c square plus 2 plus 2bc plus 2ac. Similarly, a square plus b square plus c square plus 2 plus 2bc plus 2c. That means what? A plus b plus c whole square here also, here also. So on simplification, we can write here cos alpha plus cos beta plus cos gamma whole square plus sin alpha plus sin beta plus sin gamma whole square equal to 0. Just we have applied the formula of a plus b plus c whole square. Here we had a square plus b square plus c square plus 2ab plus 2bc plus 2c. Here also a square plus b square plus c square plus 2ab plus 2bc plus 2c. That gives us a plus b plus c whole square. Here also a plus b plus c whole square. When sum of the two square is 0, then each of the part is 0. That means this implies cos alpha plus cos beta plus cos gamma equal to 0. Has to be 0, otherwise you cannot get 0. And sin alpha plus sin beta plus sin gamma equal to 0. So that is the first part of the sum. Here we had here cos beta minus gamma, cos gamma minus alpha, cos alpha minus gamma equal to minus 3 by 2. We had to put this one first, and then from there we have to reduce this one. So what we have done, we have taken 2 on the left. We have simplified this just by the formula cos a minus b formula 2 cos a cos b plus 2 sin a sin. Same for the other two parts also. Here we had a 3 on the right hand side, so minus 3 on the right hand side. So I have taken on the left hand side, change of sign with change of sign. We got plus. This plus 3 has been split up as 1, 1, and 1. This one is cos square alpha plus sin square alpha. Next one is cos square beta plus sin square beta, and then cos square gamma plus sin square gamma. After that, I have taken all cos together in one bracket, all the sin together in the other bracket. Now this is what a plus b plus c whole square format. We got the sum of the two squares is 0, individually the factors are 0. Now after that, the next part is saying cos beta minus gamma, cos gamma minus alpha, cos alpha minus gamma equal to minus alpha. Now if we take us one part, cos beta minus gamma, the first thing to understand here, in cos beta minus gamma we don't have alpha. In cos beta minus gamma we don't have alpha. So what we do, from these two part which we have got, suppose this one I mark as 1, this one I mark as 2. Now what we from this one, what we can write? Cos beta plus cos gamma equal to minus cos alpha. And from the other part, what we can write? Sin beta plus sin gamma equal to minus sin alpha. Now these two equations square and add. Why? Because our intention to eliminate this alpha. So you've seen already taken 1 and 2. So you can write here 3 and 4. Now squaring and adding 3 and 2. Now squaring and adding equation 3 and 4. So what we'll get? We'll get cos square alpha plus sin square alpha equal to cos beta plus cos gamma whole square plus sin beta plus sin gamma whole square. Now cos beta plus cos gamma whole square, we can split up this one. Cos square beta plus cos square gamma plus 2 cos beta cos gamma. From the second part, we can write as plus sin square beta plus sin square gamma plus 2 sin beta sin gamma. Now, when we add this, what we get? We get 1 here. This is also 1. So this is 1 plus 1 plus 2 if we take common. It is cos beta cos gamma plus sin beta sin gamma. So this will be 1 here. So sin square plus cos square is 1. And if we simplify this and this cancel out, what we get? We get cos of beta minus gamma equal to minus half. Because here we can see 1 cancel out, this one is coming to the left, so minus 1 by 2 minus half we get. Now here we have eliminated alpha and we have proceeded the sum. Similarly, next case we can eliminate beta and then we proceed, and last we can eliminate gamma and we can proceed. So what we can say after this, that similarly we can write cos beta equal or minus cos beta equal cos alpha plus cos gamma minus sin beta equal sin alpha plus sin gamma. Now this we mark as 4, this we mark as 5. Again squaring and adding. Squaring and adding. We can eliminate beta and we can take cos square beta plus cos square gamma equal to cos alpha plus cos gamma whole square plus sin alpha plus sin gamma whole square. This is 1. This is giving us cos square alpha plus cos square gamma plus 2 cos alpha cos gamma plus sin square alpha plus sin square gamma plus 2 sin alpha sin gamma. Now, if we add up, this will give us what? This will give us 1. This is giving us what? This is giving us 1. So this is 1 plus 1 plus 2. You can take common. Cos alpha cos gamma plus sin alpha sin gamma. Now here what we understand, that this is 1 and 1 cancel out. Here what we understand, that 1 and 1 is getting cancelled out. And here we'll take 1 on the left hand side. This one cancelled out, and this one we will take on the left hand side. So what we'll get ultimately This is minus 1 equal to 2 into cos of alpha minus gamma. So this is cos of alpha minus gamma equal to minus 1. So same way, same procedure. Last one, we'll write similarly. Similarly, we have put here the two parts. The first part was beta minus gamma. Second part, we have done the same way, alpha minus gamma. Now, alpha minus gamma, gamma minus alpha is same. Why? Because cos of minus theta is minus cos theta. So this one we can write cos of gamma minus alpha also. So similarly, the last part is what? Cos of alpha minus theta. That also you can find the same way. So we will write just similarly cos of alpha minus beta equal to minus half. Hence we have done. That is here all the parts what we have shown, it is equal to minus half. In all the three parts, it is coming what? Minus half. This is minus half. Next we have shown this one also minus half, and similarly this one also minus half. It is given alpha not equals to beta. A tan alpha plus B tan beta equals to A plus B tan alpha plus beta by. Whatever we show, this is the part given to us, and the part which we have to show, that is cos alpha by cos beta equal to A by B. This is equal to be shown, and this is the given condition. Now, this is the given condition. This is what we need to show. First of all, if we see what we need to prove or what we need to show, basically here we understand that A and B is isolated. Here we have A plus B, but we don't have A plus B type of thing here. That is just we have to isolate A and one point. Secondly, we are having here tan, but ultimately in the proof we need in terms of cos. That means what? We have to split up this tan to bring it in terms of cos and sine. Why? Because in the ultimate proof we need in terms of cos. So from the given information, start right now. Given A tan alpha plus B tan beta equal to A plus B tan alpha plus beta by. Since A and B has to be isolated, we take all A together and we write tan alpha minus tan alpha plus beta by equal to B into tan alpha plus beta by minus 10. Now, since we need the proof in terms of cos, so we'll split up in sine and cos. That is sine alpha by cos alpha minus sine alpha plus beta by whole divided by cos alpha plus beta by. This one B into sine alpha plus beta by 2 cos alpha plus beta by 2 minus sine beta by cos beta. Basically, in this step, we have simply splitted tan as sine by cos. Here also sine by cos, here also sine by cos, here also the same thing. Now, after this, we will take LCM. Cos alpha plus beta by 2. Now, sine alpha into this one Just the LCM, sin alpha into cos alpha plus beta by 2 minus cos alpha into sine of alpha plus beta. Just we have taken the LCM. So this into this minus this into this equal to B cos beta into cos alpha plus beta by 2 LCM. Then sine alpha plus beta by 2 into cos beta minus cos alpha plus beta by 2 into sine beta. Just we have taken the LCM. So this into this minus this into this. Now sin A cos B minus cos A sin B. Sin A cos B minus cos A sin B is a formula which we have done. Sin A minus B. A into sin A minus B whole divided by. Now we can see here this part will get cancelled out. You can see here that this whole portion and this whole portion gets cancelled. Now we are left with what? We are left with only cos alpha in a denominator. Here B into, here also sin A cos B minus cos A sin B. What is that? Sine of A minus B minus B whole divided by cos B. Now, if we simplify this will be what? Alpha by 2 minus beta by 2. This will be what? Alpha by 2 minus beta by 2. So these two things are same. These two factors are exactly same. Both are giving us what? Alpha by 2 minus beta by 2. So this and this will get cancelled. So A by cos alpha equal to B by cos beta. So what we take here? A by cos alpha equal to B by cos beta. If we cross multiply, cos beta by cos alpha equal to B by A. If you want to write in the form of cos alpha by cos beta, that also same issue. A by. So here what we have done, it is alpha not equal to beta. A tan alpha plus b tan beta equal to A plus B tan of alpha plus beta by 2. This is given information. Now here what we have to do? Cos alpha by cos beta equal to A by B. That is what we have to show. Now given is what? This expression. Now from the given expression, what we understand? That here we have to isolate an. What do we do? We have to isolate an. So A I have taken common. So from that what we get? Tan alpha minus tan of alpha plus beta. Basically we're trying to isolate the thing. We're trying to isolate the whole thing. So in this case, if we try to isolate, what we get? A together on one side, B together on the other side. Now this part what we had, tan alpha, that is sin alpha by cos alpha. This is also sin alpha by cos alpha. So both we have speed up in sin and cos and then simplification. Now all of you know sin A cos B minus cos A sin B formula. There is sin of A minus B. Here also sin of A minus B. And then we have simplified to get the required answer.